So next we're going to talk about the passive sign convention, but let's review some of the circuit variables. We started off with the circuit variables I, current, voltage, and power. These are our circuit variables, and our fundamental variables are work and charge. Usually we work with these set of variables because they're easy to measure. Once again, voltage is termed an across variable because it takes 2 points to measure a voltage. Here again, we can mathematically describe voltage as the derivative of the energy required to move a coulomb of charge. Alright, so this is the amount of energy required to move a charge. On the other hand, current is a through variable because it only takes 1 point, either A or B, to measure the current through this device. And mathematically, current can be defined as the derivative of the charge with respect to time. So basically we're counting the number of charges at a particular point in the circuit. And then finally, power is defined as dW dt, where W is the energy and T is the time. So it's the amount of work you do or expend per unit of time. Now we can derive the relationship between power, current, and voltage once again by rewriting dWdt as follows. We can have dW dq and dq dt, so a chain rule type of effect. But we note here that dW dq is really the voltage and dq dt is really the current. Therefore, power is equal to IV. And again, I mentioned earlier the acronym poison ivy is a good way to remember this formula. So what do we mean by the passive sign convention? Well, here in this drawing, we're given the rest of the circuit shown here and some device connected to this circuit. I have what we call nodes A and B are connected to this circuit. Now, by convention, if I assign a current in this direction as a reference, then I must assign my voltage as plus on top here and minus at the bottom. Now, this doesn't explain what's happening in the circuit, it just serves as a reference point. So if your answer, either the current or voltage, is positive, then you chose the right direction as your reference, as well as selecting your polarities of positive and negative with the voltage. However, if your answer is negative, that just means that it's opposite direction that you selected as a reference point. Now, passive sign convention says if the power, the product of current and voltage here, is positive, that implies it absorbs energy. Now, if it's negative, that is the power, then it means it delivers energy. So an example of one device absorbing energy is a resistor, such as a light bulb or a toaster. They can be modeled as resistors in essence. And negative delivers energy is of course like a DC power source, such as a battery. So hopefully that clears up the passive sign convention, and we'll go through an example on how we assign the direction of the current. Either you pick a direction and that governs what the reference marks for voltage is, or you pick the voltage and that governs the direction of the current. They have to be consistent with one another.